Good morning. Welcome to this webinar Respected Community for the National Plans for Adaptation of Climate Change. My name is Lily Ileva and I'm going to be the moderator of this webinar. If you can indicate in the chat on the left, on your right, if you can hear me well. Can you hear me well? If so, please write on the chat to your right. For those of you that have never used the platform before, you can choose the language on the bottom right hand corner, and it says your language, and you can choose whether to listen in the webinar in English or Spanish. If you have any technical problems, please click on the question mark located on the bottom left hand corner of your screen. If your screen freezes or the audio just cuts, please do refresh the browser. Please. I suggest for you to use the Google Chrome browser so you can work better. We will start. I would like to introduce the Practice Community PRENAC. It's an initiative from environmental initiative through the Regatta program. This initiative is being implemented in collaboration with Practical Action. Community of Practice for elaborating the National Adaptation Plans for Climate Change offers the officers and stakeholders involved in the elaboration of these adaptation plans of each country in the Latin America and the Caribbean the opportunity to support each other through the exchange of good practices and challenges in this matter, and in order also to receive support and contribution from researchers and specialists from the international community and the civil society. So this exchange is done through this knowledge portal. We have different discussions regarding different topics, different modules, and also as a series of webinars just like this one that you are assisting now. Today's webinar is part of a series of webinars, and it's the first webinar. I have the pleasure to welcome our participants, Dr. Jorge Lopez Blanco. He is the Director of Risk Management and Adaptation and Coordination for Adaptation for Climate Change of the National Institute of Ecology and Climate Change in Mexico. And also Dr. Valdo Lavado Casimiro, researcher for the National Direction of Hydrology and Water Resources, Meteorological Services, and also named Tsunami in Peru. Today's webinar will have a presentation from Dr. Blanco. Here he will present his experience in Mexico for adaptation to climate change, that experience, the application of that experience in climate change and impact of climate change, and analysis of current vulnerability and future vulnerability. All this in Mexico, and also will have definitions of adaptation measures. I would like to say that the questions will be the question and answer session will be done after the presentation. We will have a brief moment with our presenter, with a speaker. We will have first the presentation, and then we will have the question and answer session with the speaker. Thank you very much, and this is a pleasure. I give the floor to Dr. Blanco. Can you hear me? My name is Jorge Lopez Blanco. I am in the direction of risk management and adaptation here in National Coordination of Adaptation in Climate Change of the National Institute of Ecology and Climate Change. Today I will talk about the adaptation process for climate change here in Mexico. I will start by saying how this process is set up as a methodology, and then I will go to the examples that what we are doing in matters of evaluation of vulnerability and some applications that were done for adaptation measures here in Mexico. We need to start from the fact that climate change is here, is present. It has been present for many decades, and it's going to intensify. The impact of this climate change is going to intensify in the near future. We need to consider that in 2014, the working group of the IPCC says that it gives a report of high trustable report that says that it says that it is extremely probable that human influence has been the dominant route of planet warming observed since the mid-20th century. They also affirm that the vulnerability analysis is a priority. For the reduction of current and future risk associated with climate change. Also that the current impacts of climate change due to this fire, heat wave, droughts, floods, cyclones, etc. They have revealed significant vulnerability and exposure of some ecosystems and human ecosystems to climate variability. And also the assessment process of vulnerability to climate change and the implementation of strategies in the adaptation process is multi-scale, multi-temporal, multi-thematic, multi-sectoral, meaning that it can be looked at from a perspective of facing the climate change of a territorial planning. I need to say also that in Mexico, in a special program for climate change of 2014, and that includes the period from 2014 to 2020, we have different impacts of climate change. For example, in the agricultural sector, we talk about the decrease of productivity of corn for the decade of 2050. There's already evidence that most of the crops will not be correct for production in Mexico. As for the agricultural sector, we can say that the country will become drier, and there will be more droughts. We won't have less availability of water at the coastal region. We can see that an increase of the level of the sea represents a danger for the settlements in coastal zones. As for storm and severe weather, we can see that even when there is a high incertitude degree, we can say that there will be an impact, especially in the tropical parts of the country, which is the north part. We also talk about ecosystems and the biodiversity that will be affected, that will suffer from this, and especially strategical infrastructure, which is an important sector, which is the tourist sector that will be impacted due to the intensity of and the frequency of the phenomenon of storms, etc. So this is a evaluation that we mentioned in this evaluation, assessment that we did. We can also say that it's a process of adjusting of the current and future climate and its effects, and also that human intervention can facilitate the adjustments from a perspective from the Framework Commission of the United Nations for the Climate Change. We talk about that the adaptation means adjustment in ecological, social, economical systems. We also mentioned that we need to do changes in processes, practices, and structures to moderate potential harms of climate change. The adaptation process by itself is a process that can be done by a territorial planning. It could be thematic or specific. That is the surroundings that is the situation where we propose this adaptation process. So this is the adaptation process, how it was conceived. We have some phases. I will talk about the phases. There are 3 phases that I consider that are fundamental in order to carry out this adaptation process. A first phase deals with the knowledge of the situation of the climate change, and this is defined by 3 fundamental aspects. First is the definition of the region of study, meaning that we need to gather information of the land Fortunately, what we do in Mexico good is that we know already the land and we have identified the different lands, but sadly we have some other types of lands that we need to identify, like for example different types of other type of lands, protected areas, etc. So in this first stage of adaptation, we have the creation of the climate agenda, where we consider the social participation for this land already identified when they studied to know that the impacts, the potential impacts. Here also we have the definition of priority sectors, where the impacts of climate change are more evident. So afterwards we will go back to this diagram of this, but that is the first number 1. Here you can see on the medium right hand, you can see that a link to the document of 2015 done by Naginek, where they talk about the minimum elements for the elaboration of climate change programs of federative entities from a perspective of mitigation, but also we have the second part of this document, we have the adaptation part. As I mentioned in this first phase, what we answer are 3 types of questions. First, what is the problem that corresponds to the climate agenda creation? Where is the problem? Meaning that what is that territory where we have that impact of climate change? And it corresponds to the definition of territorial regionalization. Who have the problem? Meaning that who are the sectors, which are the sectors prioritized? The definition of the prioritizing areas, the ones that are most affected by this impacts of climate change. This corresponds to the first phase, that corresponds to the characteristic geographic characterization, the problematic of the climate change, where the public participation is fundamental, especially in the climate agenda creation in order to define this agenda. Then, within this first phase, we have the evaluation of biophysical conditions or climatic conditions, where we evaluate the climatology, variability of climate change, extreme events, and scenarios of climate change. In this case, we mention the ones updated by the report of the 5th IPCC assessment report. Here you can see on this line, you have a link where you can review the platform, where we have the scenarios of climate change that we are considering in Mexico in order to carry out the evaluation in near future or far future. Here you have an example of the French model with a reserve in the near future from 2015 2039, the variability for maximal temperature for January, and we have this in this context territorial of municipality. We have also the states of the country, there are 22, and also to the right up hand corner we have the type of model of the RCP type of model, and we point out the resolution of this. We have 30 seconds in geographical coordinates that correspond especially to a 1 kilometer by 1 kilometer of resolution. In this case, that is the scenario of the climate change. Within the platform, we can have, as an example, here the conditions of maximum temperature for an RCP of 8.5 watts of by square meter in July, for example, with a far seasonal horizon of 2075, 2099, and we have the model that we are using in order to carry out the consideration of the future climate. This is the French model, we have the American model, we have the English model, and we have the German model. So these are the conditions for a particular month mentioned before. So that is the platform that I mentioned. And then we have the process, the phase 2 of this process of adaptation. This is fundamental because it corresponds to the vulnerability assessment, considering the foreseen climate, the scenarios, and dimension of the society. So those are the three components in order to evaluate the potential impacts of the different sectors that correspond to the sensational sensitivity. And we have the third component, which is the assessment of conditions of natural resources, human resources, financial resources, political resources, the state, etc., which is goal at the international level in adaptative capability. So this is evaluated in the second phase, and we are considering the phase number 1, and then we do the assessment and do the vulnerability assessment in the phase number 2, which is the next slide, where we can see what is the approach. This is a approach evaluation of vulnerability to climate change, as it was mentioned in 2017, 2007 by IPCC, by other authors also. In this case, we have this schema that we are considering that climate variability, climate change could be seen in exposure, current and future, and sensitivity, current and future, as negative aspects that have a negative impact and generate a potential impact. We have the adaptative capability, current and future, that counters this potential impact in order to define at the end the dimension of vulnerability, current and future. So that is the approach of vulnerability that is applied and the considerations of the adaptation process. And also I would like to mention something quite general. Us, from the need of having this evaluation of the vulnerability in the country, in the whole, in different regions, we are building the National Atlas on Climate Change Vulnerability that is programmed from 2014 to 2018, that it corresponds to the objective number 1, which is reduce the vulnerability of strategy 1.1, develop and consolidate and modernize the instruments needed to reduce vulnerability to climate change, and it corresponds to the line of action 1.1.1, which is to consolidate the National Atlas on Vulnerability to Climate Change. This is the surrounding at the territorial level. We can see here a screen from the National Atlas of the Vulnerability of Climate Change. There's a map visualizer, is a website where you can see on the left hand, where you see the chart, corresponds to the evaluation of vulnerability of climate change. We are considering different hierarchies of territory. In this case is the political initiative degree with a municipal district, with a focal topic with the human means economical and sub-focal team, which is agriculture of corn. And this map showed here is the map of current exposition. It corresponds to the current exposition, considering a data from 1950 and 2000, and it corresponds to the temporal agriculture of corn in Mexico. So that is an example that what is being assessed. And here is a regional view how we evaluate this conception framework of vulnerability. The territory is municipal, the focus team is agriculture. Vulnerability as a function of exposure, susceptibility, adaptive capacity, we consider a conceptual model of adaptation. We consider more than 50 variables and indicators, and the current vulnerability is it's a model where we consider the exposition to sensitivity minus the adaptive capability, and before that we have the normalization done by all these variables. So we can have some results where the variables, for example, for the exposition index, we have here 5 sub-indices. We talk about droughts, floods, etc. We have the problematic index where we see the environmental problems, etc. The production units by a climate sub-base sub-index where we consider minimal temperature in different conditions in the history, and we have the projected climate for the models, the HATSM and the RTPI model, the MPI model that is for the exposition index, that one of the components of vulnerability. Here are the maps. They are in the National Atlas of the Vulnerability, and they correspond to the current exposure index. On the top and on the bottom we have the other indices for HAPTE, and we have bottom right we have the exposition index, which is the German model under this condition mentioned before. For the sensibility we have 4 sub-index for population. For example, in this case, just as an example, we have the population of household with female house heads, municipality, or percentage of less than 5 years who speak indigenous languages. In the case of health sub-index, we have the percentage of low size birth. In basic agriculture sub-index, we have the percentage of land surface before temporary agriculture by municipality. We have the production, in this case maize, and the last sub-index, which is the future agriculture, considers the land capacity for temporary maize that was mentioned before. So these are the sensitivity maps, current and future, at the municipality level and other level, as I mentioned before. In the case of the index of adaptive capacity, we have the human capital, social capital, financial and natural capital. And that limits the assessment of future capability. In this case, we only have one variable that considers the rate of population growth from 2010 to 2030 that we're considering this in order to evaluate the capacity for the future. These are the adaptive capacity, the current municipal adaptive capacity indexes for the maize, and we have the future municipal adaptive capacity for the same case. We have also 3 maps, which is the dimension of the municipality level, but vulnerability, the current and the 2 future conditions. Using this models at the municipality level for the municipalities of Mexico. Not only the temporal agriculture of maize is included here, but also we have other focal points, focal themes, and I'm showing here 3 other maps regarding this current sensitivity of biophysical resources for the vegetation, and this shows how it could change under these conditions. Using this model, how vegetation would change projected in the future in different climatic conditions, in this case of for 2075 and 2099. And also we have the future sensibility index with that horizontal projection. We go now to the first number 3 of this adaptation process. Here we can see that within this phase we have 4 aspects that are fundamental to give adaptation measures. What is the approach for the adaptation process? We consider 3 approaches. We have also the proposal of adaptation measures, and that we include the participation of society. We have also the prioritization of adaptation measures. So the measures, we have the design and the implementation of these priority measures that were chosen, and finally we have something that is fundamental of this process, which is the monitoring and the evaluation of the adaptation measures. So this is the 3rd phase of the process that we are considering to implement in Mexico in order to carry out these adaptation measures. As I mentioned, that we have 3 approaches that are fundamental. First, the ecosystem-based adaptation that considers the use of biodiversity and ecosystem services. We have also the adaptation based on human communities, where the main objective is to improve the capacity of local communities to adapt to climate change. And the 3rd approach that is quite important, that needs to be considered with the whole strategy, the global strategy, which is the adaptation based on disaster risk reduction. And the main objective of this is to anticipate the future of disaster risk, reduce existing exposure, improve recovery capacity, and reduce vulnerability of the ecosystem. So those are the 3 approaches that we are considering. They are not independent. In the case, for example, if you have a territory, we consider the 3 types of approaches, considering the different problems that we have, and considering what we want to resolve, and considering the problems, the most important problems that we have, that we can see in those territories. So from these approaches in this adaptations process in phase 3, we answer 3 fundamental questions of the process, which are: what is the integrative methods approaches, meaning what are the approaches to adaptation for climate change? What are the solutions proposed, which would be the proposal for adaptation measures? How to implement these solutions, which corresponds to the prioritization of adaptation measures? What follow-up corrections to do, which is the design and implementation? And then what sources and we'll go to the monitoring. And something that is fundamental is what are the sources of funding that we have in order to carry out these adaptation measures. In the top part, we mentioned 2 fundamental aspects of this 3rd phase, which is the prioritization of adaptation measures that are in the function of the problem identified in the climate agenda, with knowing the vulnerability analysis, with the participation of social actors. We propose measures to respond to identify a problem, and some other thing that is fundamental, which is the monitoring and evaluation, where we include the population. We carry out evaluations that are transparent. We disseminate this result to the population, and we evaluate the impact of these adaptation measures, and we carry out the follow-up. As an example of this adaptation, we carry out this project, which is the implementation of the pilot, which is a project of international financing. It's a project from the World Bank group. In Mexico was conducted by two institutions. As we can see on the top part, we can see all the participants in Mexico that intervened during this project. We have many actors, like the Ministry of Environment in Mexico. We have 3 pilot areas, all of them in the part of the Gulf of Mexico and in the Caribbean, in the part of Intermanuel States. So those are pilot areas in Veracruz, located to the east of Mexico, in the Gulf Coast of Mexico. There we carry out implemented of pilot measures in the Papaloapa River. So we carry out replanting of mangrove, etc., and we have the result of these implementations and some images where you can see the actions of reforestation, the conditions of the chinampas that were built in order to improve the conditions of reforestation of mangrove. We also carry out the cleaning, and we can see the people that benefit of this process. So this is one of the examples that we implemented in Mexico as part of this project that finished last year, at the end of last year, and that we want to have it as an important reference as to carry out adaptation measures. In this case, in Mexico, it can be Mexico, but it can be considered for other type of territories, other countries, and also these represent one of the first direct implementations integrated with studies carried out in Mexico. In this project, within the same project, we have the implementation of adaptive pilot measures in the Carmen Bajonal Machona, which is the Tabasco state. Here we carry out the reforestation of mangrove, and then we carry out the drain cleaning and manual cleaning. And also in this same territory, we tried to improve the conditions of the knowledge of the deforestation through education. We also installed radios that allowed to implement a early warning system facing extreme meteorological events. And also we talked about reforestation of mangrove, etc., the cleaning of drain, and there were many people benefit. So this is a summary of the adaptation process in Mexico, and thank you very much for your attention. If you have any questions, I will gladly answer your questions. Thank you very much. Thank you very much, Dr. Blanco, for giving us the scenario of the development process of the national adaptation plans in Mexico. Was a long process and complex process, and so thank you very much for sharing these phases with us in this process. As I mentioned before, we will have a discussion panel with Dr. Eduardo Casimiro, and then after this panel we will have a question and answer session from participants. So if you can, please write your questions on the chat. During the panel, and if, of course, when asking your questions, please introduce yourselves, what is your organization, and ask your questions, and after the panel we will answer your questions. After the presentation of Dr. Blanco, we have a discussion panel where we invited Dr. Casimiro. He's a researcher of the National Direction of Water Resources in the National Service of Meteorology in Tsunami, Peru. He will talk about his experience regarding the scenario for a study of economy of climate change here. I would like to introduce briefly the context of this study, and then I will give the floor to Dr. Casimiro. So this study deals with the economy of climate change in Peru. So it addresses how climate change will affect the economic situation. So this research was done at the country scale based on the different reports, especially the Stern Review and IBD-CELAC. It is supported by a consortium of the Agraria University in Peru and Practical Action and Global Climate Adaptation Partnership, and that was requested by the government of Peru and the support of the SDEC. So, as I mentioned, a source for this study was the Stern Review. So this report, shows that we need to act early facing the generated risk or enhanced or stress risk before assuming costs related to climate change. This study was basic information in order to support activities and more information to carry out measures for climate change adaptation. It was the IPCC report was used and the scenarios of A1B and A2 and B2. It shows that in the absence of actions to cope with the climate change, the Peruvian economy would face considerable economic costs. The study uses 7 models, generates 19 future stories, and considers ecosystem projections. As for the methodology, you can see here that the methodological scheme for developing the study methodology to use projects the future climate. It evaluates how the climate modifies the natural resources, identifies the potential change in production activities that are most involved to the climatic variables and even its importance, like for example the livestock, hydro energy, agriculture, fishing, mining, tourism, and 2 sectors that condition the productivity, which is the infrastructure and health. Also, study measures the added value in terms of change. of GDP within a scenario of climate change. In order to evaluate it economically, this economic impacts of climate change up to 2100, the year 2100. So this document can be downloaded with all the results. I will share the link with you so you can download it and read it. For our discussion panel, we will have the intervention of Dr. Casimiro, who will share a little bit more information regarding his experience, especially regarding the scenarios for climate change. And we prepared two specific questions for the discussion panel. And these two questions are: what were the challenges in developing the climate scenarios for this study? How did you overcome these challenges? And how similar challenges for modeling scenarios in the other countries can be overcome? So with these two questions, I would like to invite Dr. Casimiro. Dr. Casimiro. So he can answer the question, and as I mentioned, we will have a specific question and answer session. Thank you very much. I give the floor to Dr. Casimiro. Good morning. I would like to thank Practical Action for the invitation. So I would like to explain what we were working here, as Lily explained. I think that the main challenge that we have when building these scenarios, more than using the scenarios themselves, because it had a great level of uncertainty given the resolution scenarios that were used for this study, because at that time we had the AR3, which is the assessment report of IPCC, and as you know, if you work with climatic scenarios, part of the second question. But anyways, the first challenge here that I worked on it, but also Guinea Awadis in Tsunami also worked. We wrote a reader of the Imperial College of University of London. The main challenge that we had was to generate climatic maps, and that was a quite good experience, because, and I will tell a little bit more the challenges and the examples that we had. But first, in the Andean countries, the main problem that we have when defining climatologies at a national scale is the space representation of the climate, meaning that the distribution of seasons in the whole country is not ideal. For example, in the case of Peru, in the Amazonas region, we don't have many seasons. So when trying to know what the weather is like in those regions without having the information, it's difficult. However, the answers that are requested, they have to include the national level. So in that context, in that situation, what we did was to carry out some geostatistical methods with the Imperial College, where we mixed information from remote sensoring with data that we had in tsunami, and we generated climatologies of high resolution and very good results using the rain meters. And this data that we generated, we applied this to the different scenarios of climate change. It's true, this scenario of climate change were quite gross. The finer one was 1.5 degrees. We're talking about 150 kilometers of resolution, and that would have an uncertainty level in some regions, for example in the Pacific basin, where we have different small basins that include the Andean part and the coastal part. So in this case, the scenario didn't make a difference of that situation. But what actually helped was it to climatologists, because we generated climatologists of, for example, 1 kilometer of resolution at the national level, and that is where we evaluated, we assessed the scenarios, which is a quite important experience. Basically, what we got to say is how we overcome these scenarios based on the scientific research, considering those were researchers done in other countries, and with a collaboration with the Tsunami and Imperial College. It was what made possible that to generate the scenarios of high resolution that afterwards were used for this study. So that was the first question. Should I answer the second question? Yes. Okay, as for the second question, it has to do what are the similar challenges that we can improve now. I think that current climatologies can be improved with remote counseling information, mixing this with station information. Of course, we do not solve the problem, but something that we always highlight is where we have a more sensitive of climatology is where we have long data climatological areas. In some of the regions where we don't have information, of course we can generate that climatology, but they will have a level of intensity linked to it. That is, since it is known, it is not information. So what is the main challenge is that currently the new scenarios of climate change of the assessment report 5 or AR5, we have some scenarios that have a finer resolution. I think it's 50 kilometers, I don't know. However, we have platforms of regional models. Actually, we have a model called Cortex. Thanks to this Cortex, we have global scenarios. In one of the cases is Peru, and these are available. I think it has a resolution of 27 kilometers at the Latin American level, so we can download this file from the Cortex website, and we can use that information in order to know how these scenarios are. Of course, I didn't mention this, but currently we have over 30 models, and what we did in the previous study was to see which model was the best. So we compared a spatial comparison of this information at the Peru level, and we arrived to get the best models. However, what we found on the Peru scale is that we couldn't say this is the best model for Peru, but we had a model that adjusted to the north part of the Pacific of Peru, another model that adjusted to the Titicaca variant, another model that adjusted to the Amazonian region, and that is where we decided the best model. So we used a lot of models, and we use an average of all those, the maximum and minimum values, and this could be done using these regional methods with a variability of space that's quite fine. Of course, we have research in Peru where we have already assessed this not only climatology in order to evaluate rain, for example, but to know how are the different atmospheric sea processes are. If we talk, for example, El Niño phenomenon, the temperature of the sea face the Equatorian zone, actually we don't have a model that represents this, and that depends of course of the approach that we're going to get when working with this scenario. What do I mean by this? We worked at the national level, so we had to define what was national scale, but if the work that we want to do is local, it's more local, we have to carry out a finer analysis. What are the values that we need to use? So I think those are the challenges, and that were overcome thanks to the remote mentoring, counseling, the information that we have. Of course, if the problem was that before we didn't have the information in order to solve the problem, now that the problem is that we have a lot of information. But out of that information, we have to decide which are the best models, the best climatologists in order to work with them. Because a great problem that I see, and I see it from worker of the National Service of Meteorology is that we have so much information currently that we can find different studies with different sources of information, and personally I think that is not the ideal thing to do. Something that is quite important that I witnessed in Colombia, they have already defined what is the scenarios that need to work with all these scenarios of climate change, and that is something that in Peru it's not defined yet. If we defined and we'd say how we need to work with these models of climate change or generate regional models, the answer to different studies done of climate change would be more homogeneous. If not, they vary a lot among themselves. So that is from the point of view of the results of the works done. I think those are the challenges that we need to work in different countries. And in that context, thanks to these studies of acceleration of climatology, mixing remote information with precipitation data, etc. In the case of Peru, we currently in Tsunami, the National Service of Meteorology of Peru, we developed information mix of remote mentoring, and we had a product called PISCO, Peruvian Interpolation Data of the What's PISCO? A grilled data that around it has at 4 kilometers of resolution, and this information comes from the 1981 up to now, and we are using this in order to monitor currently floodings here in Peru. We use it for monitoring the floods, to carry out hydrological materials, because it is an information with a quite high sensitivity level where we have climatological information, but it's not very correct where we don't have information. And that allowed us to understand some of the answers answered by the government of Peru at a finer scale, whether department, municipality, etc., which is the political division of Peru. And those are the challenges that we have for the future. We generated that grilled information, but now for the next 3 months we will have information regarding maximum and minimum temperature in order to include all this information and models, because our final objective is to generate discovery and flaws at the national scale. So this is what is interesting of this study where we participated, and that allowed us to have a more future vision for improving information, weather information. And I think that the most important thing to improve this type of climate scenarios is information. Without data, without information, we would have a lot of gaps, and I think that in this case of the Peruvian case was important. Thank you very much, Dr. Casimiro. Thank you for sharing your experience regarding challenges and how can we overcome them based on what was done and what is being done in Peru, but also refer to the regional level. As I mentioned, we have a question and answer session with participants. We documented some of the questions, and if you have any more questions for Dr. Casimiro, please, if you could put them on the chat. I can read some of the questions now. Sonia asks, how do you include all scenarios of climate change in evaluations of threats? Do you select one? Do you carry out examples? How do you inform the locals for the scenarios? That is always a challenge when we work with climate change scenarios, and people always want to know what is going to happen in the future. I will read the other questions, and I will give the floor to for answering the questions. Doroteo Cárdenas. to assess what are the meeting points and divergence points considered that risk management plan should have. As for the climate change, we have also other questions from Angelico Espina. Can you please clarify if Mexico is already in the third phase of implementation, or the stages are implemented in parallel? What are the following next steps in the national adaptation plans in Mexico? And one question of Mexico, of Wilson Legion. I write from Ecuador, from the Consortium of National Government. I would like to know what was the process to develop the plan at national level, positive and negative aspects of the process. So, Dr. Blanco, you have the floor to answer the questions. Thank you. One of the questions corresponded to how do you inform the local people of the results? One of the things that were mentioned here is that we are working at a municipality level, but as I mentioned, in the case of the scenarios, the predictions that we consider, we are considering the 4 climate change scenario with the 4 models that I mentioned. The French, the American, the German model, etc. Those models are analyzed in the first spatial resolution from an interpolation of original data. They are found in kilometers 5.5 by geographic coordinates of latitude and longitude, and the resolution was integrated to this Hitman's information of 2005, which is a world methodology with high resolution. And this information, we have a consideration of the frequency of the data, and the result is applied to the whole municipality. Of course, we have a generalization process, but in that way we can have information on the climatic conditions for agriculture, for example, in terms of a general management of the values for the region. Of course, this represents a high center of uncertainty, but many of the variables are considered for evaluating this, especially in the sensibility conditions and the adaptive conditions, are given at the municipality level by the economic census, population census. So that is how we integrate the evaluations at the municipality level for the country. One of the questions mentions that we carry out an integration of 4 models. We carry out actually an average of 4 models. And actually that is not the case. As I mentioned, the hacking for the English model, the results that we obtain, the variables projected for precipitation and temperature are being considered independently of the other models. We are not averaging the 4, but we are analyzing independently the 4 models. So we have 4 conditions based on the models that we have. One of the questions mentioned that if we are in the adaptation process, is it a parallel process? In the case of the Gulf of Mexico for the wetlands, we followed a initial evaluation process of climate change adaptation of the territory, and then we did a evaluation of local vulnerability and the current climatic conditions and projected conditions for then finalizing of with the third stage. In this case, for the example that I mentioned, for adaptation measures, we have a linear process by phases, so it could be integrated. In other cases, for example, for the studies in Mexico, the process that we are following is parallel, meaning that we are evaluating the climate change conditions, the vulnerability conditions, etc. But actually, the part of adaptation measures is for later degradation of climate change. As for the adaptation measures, going back to this process of Gulf of Mexico, it's a local implementation process where we have the participation of the people for carry out these adaptation measures. It's a continuous communication. The people participate in this. So in that sense, the communications of evaluations, previous communications regarding what is known at the local level of the possible impacts of climate change or historical impacts is being done in that situation, the application of those situations, the communication of interaction with people, the participation of people for the realization of such. For example, in the case of the Gulf of Mexico, the wetlands, the mangrove reforestation, a lot of the people that participated in this is local people, meaning that there were people that were interested in supporting these measures. So adaptation measures of implementation, it is a process given at the local level where interaction with people is fundamental, and communication not only of scenarios of climate change but also of other aspects that are included within this, to include people for them to participate in this measure. I don't know if you have any more questions. Thank you very much, Dr. Blanco. I think that we have answered all questions from participants, and we have two more questions for Dr. Casimiro. One of the questions is from Wilson. With the generated information from Peru, can we generate climatic scenarios at a national level? What would be the level of uncertainty? And with Machado, we have another question from Wilma Machado. The variety of original scenarios, how can we generate this and not lose valuable information when doing this? So where is Dr. Casimiro, you have the floor. Thank you, Lily. As for the climatic scenarios, at the regional municipal level, we have to make the difference among two things. To generate these scenarios, climatic scenarios, in order as great impacts where we work with this scenario. This part of the generation of climatological information, and this other part has to do with the creation of climate change, creation of scenarios. So we have to make the difference between the two. These scenarios of climate change, generally what we know that they have a tendency to make mistakes, the overestimations or subestimations, but it depends on what we want to research. We need to carry out a process called downscaling. Maybe all of us have already heard of downscaling. What we try to do is to take this information of the scenarios of climate change to the scale of seasons. That is why I said that one of the great novelties that we did in Peru is that we have a grilled information. Where we have information with such a radius of information. Having this fine information, we can have a more political resolution, which is the district at the district level. When we have this information at the district level, we do a downscaling of the scenarios of climate change, whether a regional model, it could be a dynamic downscaling, a statistical downscaling, it could change regarding the methodology managed by different institutions in this country. As I say, the finer moments at the national scale, 25 kilometers, those are the finest. When we have this fine information we could have a regional municipal scale as the question asks. Now, what is the degree of intensity? The degree of intensity is linked to the climatic information that we work with. One of the things that we clarify with this information is that it has which has a fine resolution. We define what are the pixels where we have more sensitivity of information. How do we determine this? Next to a station where we have a radius of influence, it would be in function of the variability of the zone. The World Environmental Organization, which is an institution that regulates everything related to seasons, says that this changes from 20 to 50 kilometers, so it changes. In the case of precipitation of Peru in the Amazon part, we can just use a more greater area because we have more homogeneous type of rain, but in the Andes we have a lot of variability of rain, so we need to reduce the area of adaptation. What is level the degree of intensity? Where we have these seasons and we have this radius, but it is outside, it will have a greater degree of intensity. We could generate this scenario, yes, but the degree of intensity will be linked to the information of remote access counseling. Next question has to do with homogenization of variability of scenarios in order not to lose information, which is true. As I mentioned in the study that we did, we need to carry out a validation of the scenarios, meaning how are those scenarios? Are they answering? Are they not answering? Some scenarios, as I mentioned, were good in some regions of Peru, for example, the North Coast, but in the part of the Titicaca Lake, there was another model that was the best, but in the Amazon basin, we had another model that worked best. So we realized that at the national level, we could not say this is the best model. So what did we do? As I mentioned, we had information regarding gross information regarding these scenarios, and we concluded that we needed to use all modules in Peru because it was at the national level. So we mixed all these scenarios. We worked with around 15, and out of these 15 scenarios, by each pixel, because we did an interpolation, it was a gross pixel, we did an interpolation of these scenarios of climate change. We interpoled with a solution of 10 kilometers using the simplest method, which is the inversion distance method. It was not a Cochrane method, basically for not removing the signal of a scenario they had to do. And after we had these scenarios, the prints at the same resolution, what we did was, out of that group of rasters, we took from much of the pixels, the average. Not only we worked with the average, because what happens in these scenarios is that sometimes we talk about percentages of change, we can say that it increases 10%. But the other can say that it decreases 10%, and you have the average and you have 0. So you could see a little loose of a colleague says, well, for not losing the information, what do we do? Is that each of these clusters, we took the average value, but also we have the maximum value and the minimum value. So when delivering the result in each area, we said this is the average, but please be careful, we have this minimum, this maximum, different scenarios. So we worked with these ranges at the time of when showing the change. Doing that, we didn't lose information. As the colleague mentioned, given scientific information, normally this methodology is good. However, as I mentioned, we have some models that represent the best model than this. And what we say is that we give weights. For example, we have 10 scenarios and we see that 5 of them are the best. We give a weight of 12, for example, but the other 5 that are a little low, we give a weight of 1. So multiply by weight and we divide, and we have more or less the average. So in that case, we could use different scenarios when doing a more fine statistical process where we give more weight to the best scenarios, and those are not the best, we just leave it aside. So that is the process that we did. Thank you very much, Dr. Casimiro, for explaining in detail what was the process and how can we overcome the challenges and the questions of participants. If you have any more questions, we will share the contacts of the two speakers in case you would like to ask questions, more specific questions. So from Practical Action on New Environment, CTCN, the Regatta program, thank you very much for your participation. It was a pleasure. We will share the presentation in English and Spanish as for the recording of the webinar. We will continue with this series of practical action, webinars. We will invite you for the next webinars in the next weeks. And have a good day, and thank you very much.